Hello, welcome to part four in our four-part series on how to design a research study. You should have previously viewed part one, in which you learned how to select a good research topic, and part two, in which you learn how to define your research objective and hypotheses in terms of measurable variables. Part three, which discusses methods of sampling, experimental units from the population, and statistical analysis methods. And in this part four, we'll talk about how to write a research proposal. And so at this point, you should already have your research study designed, and we'll just learn how to put it down on paper or in a PowerPoint presentation in such a way as to convince your audience that it is a well-designed study that's worthy of funding or conducting and has a high probability of success. However, I often find that the exercise of writing the research proposal alerts me to some inadequacies in the design, and you may need to go back to the previous steps and modify the research design once you start trying to describe on paper why you came up with that design in the first place. So, what elements does a research proposal need to contain? Typically, we would expect to see at the beginning some type of executive summary or abstract, followed by a background section which discusses the prior research on similar topics to what's being proposed and establishes the uniqueness or innovation of the study that's being proposed compared to that prior work, and establishes the significance of the topic. And then that's followed by a section that describes how the research will be conducted. And that's followed by the qualifications of the research team and the research location to conduct the research, followed by a budget section. The executive summary. An executive summary has a wide variety of structures depending on the reason you're writing the research proposal. And it could be simply an abstract, and it could be a specific aims page that lists the objectives and hypotheses of the study. And in some research proposals, we find both an abstract and a specific aims page. It depends on who you're writing, who your audience is going to be, and whether or not you're competing for government funding for your project. And so a typical structure that is concise yet gets the message across adequately, I find, is one or two sentences about the significance of the project, and one sentence about the overall objective, a sentence about each hypothesis, and after each hypothesis, between the hypotheses, you should probably put one or two sentences providing the rationale for why you think that hypothesis might be the case, what evidence your hypothesis was based on. And if you are competing for research funding and there's a certain amount of allotted maximum space, then I would use the remaining space to brag about how qualified your research team is and how innovative the approach of your project is. And typically, this executive summary will be found at the beginning of the research proposal, but I wait until the end to write it because it's really a summary of a lot of the other sections that we're about to cover. And writing those sections first helps me to think about the most succinct way to phrase each of the sentences that we would like to squeeze into a brief executive summary. Moving on to the background section. You need to use this section to establish the large potential impact that your study could possibly have if successful. And you need to talk about that in terms of the significance of the problem that you're trying to address and the significance of your study to addressing the problem. So what do I mean about the significance of the problem? How could we communicate that to our audience? So the first way, I would recommend using both of these methods. And I start off typically by describing the prevalence of the problem. So that could take several forms. If it is a disease or a product that doesn't work as well as it could, or something that fails prematurely, then how many people catch that disease? How many people use that product or have that product placed in them per year? Or you could describe it as what percent of the population is affected by it. Or you could describe it in terms of an underserved population that is more affected by the condition than the general population. And then the second thing that I would comment on is not only how often the problem occurs or to how many people, but each time it occurs, what is the impact, the individual impact? So is it a really dangerous situation? Is it life-threatening? Well, you would definitely want to mention that if it could be a deadly situation. But maybe it's not. Maybe it's in terms of aesthetics or chewing efficiency, something less than life-threatening. And but maybe you've chosen to research this anyway because it has a large dollar impact, and so you can address how much it costs dentists, how much it costs each patient when it occurs. And in addition to establishing the significance of the problem, you need to talk about the significance of your study to the problem. So if your study is successful, what type of impact is that going to have on the problem? And to do that, you need to talk about all the work that has been previously done in the same area and point to a hole or a need that your study is hopefully going to fill when it's successful. You've seen this list before, so I'm not going to spend very much time on it. This is our list of reasons why studies are typically noted to be significant. And so you're going to want to draw from one or more areas on this list when noting what the negative impact of the problem is on the patients, the clinicians, or on society that you need to address. And then we have some optional information that is often but not always included in the background section. And one of those is discussing the innovation of the project, and the other is a list of preliminary data that have already been collected. So the innovation, if you have a truly significant problem that you're addressing, then chances are somebody else has tried to address it previously. And so you'll need to describe what you're doing differently, how you're addressing a different part of the problem, or why your approach is different and is going to be successful, whereas previous approaches were not successful. If you're writing your research proposal to the NIH, National Institutes of Health, for funding, they specifically require in their current format that you have a section of the background labeled innovation and that you would address these concepts in that section. Under preliminary data, maybe you don't have preliminary data, or hopefully you do. Preliminary data are data that you gather, usually doing the same type of experiment that you're proposing, hopefully on the same population that you're proposing to do your study on, but maybe just a few data points, not enough to give you sufficient statistical power to draw any conclusions. But what these data points will allow you to do is they will provide the rationale for your hypothesis. If that can't already be found from somebody else's results in the prior literature, then you may collect enough data to suggest a direction that the hypothesis should go in. And the data, maybe the most important role of the data is to demonstrate your experience with using the research protocols that you're proposing for growing the type of bacteria that you plan to use, culturing them successfully, working with the type of animals you're proposing, using the type of test equipment that you're proposing. And then another thing that preliminary data can do is be the basis for your statistical design. As we discussed in the previous lesson, lesson 3, in order to conduct a power analysis to determine what your sample size should be, you need to have an idea of how much standard deviation to expect in your results, and you can get that from a few preliminary data points. Next, we have the research design section, which is typically the bulk of a research proposal. And there are two main parts that we expect to find in a research design section. One is a general overview of the entire study or project describing the workflow. And the other are the specific protocols to be used in manipulating or measuring specimens. And so in the workflow section, and in the next few slides, I'll provide specific examples of each of these. But one thing that we may find are flowcharts, and we're especially likely to need a flowchart if it's a large project that contains multiple studies and many hypotheses to show how those are coordinated with each other. Something that we almost always find is a tree diagram indicating how our sample of specimens or test subjects is allocated to the various treatment groups and how each treatment group is going to be measured to provide response variables and at what time intervals they're going to be measured. And then we should also have a timeline that will help to convince your readership that you're capable of conducting the research in the time allotted. In the protocol section, you should define the materials to be used, what compositions they will be, where they're going to be acquired from, why these materials were chosen instead of different materials. And you should specify the methods that are going to be used to handle the specimens and to take measurements from them. But don't make the mistake that many investigators make, and that's to forget to describe the statistical methods that have been chosen to analyze the data, the sample size or number of specimens per group, and statistically how that sample size was determined ahead of time. This is an example of what a flowchart might look like for a complicated project with multiple objectives, and many hypotheses. It may not be necessary to use a flowchart in a simple study. So we're showing here that we are synthesizing some experimental materials that we would like to investigate that hopefully will have superior properties to materials that are currently commercially available. And then those will go through an initial screening to eliminate many of them before we go on to more time-intensive and more expensive tests and optimization. So we try to weed out the materials that don't look like they have as much potential immediately to save time and money in the project. In this case, MTT assay to determine cellular activity. Lack of cellular activity indicates cytotoxicity. And so if it's not 80% or better of the activity we have in contact with tissue culture polystyrene, then we say it's a cytotoxic material and we're not going to investigate it anymore. So we exclude it from further study. However, all the materials that pass this initial screening go on to have more time invested in them. And so we could go ahead and take each of those materials, mix them with triethylene glycol dimethacrylate to cure and make comonomers. We can mix them in a variety of ratios, one for each material that passed the screening, one set of ratios for each material that passed the screening. And then those can go on through a curing shrinkage test with 5 specimens per group, and a test of resistance to degradation by water with 3 specimens per group. And we compare the data from all the different comonomer ratios and the different isomers to select the one with the best resistance to degradation by water. And then we go on and look at the curing shrinkage. If the curing shrinkage is too large, if it's larger than 3%, then that particular material is unacceptable. It may have the best hydrolytic resistance, but we just can't use it. So then we go back and we select the one with the second best hydrolytic resistance and look at its curing shrinkage. And so on until we get the best one that can pass the curing shrinkage screening. And then we go into further tests where we add ceramic filler particles and different volume fractions and try to optimize a product that may be a new prototype product and may be brought to market. We do testing on the diametral tensile strength, the wear resistance, and if it passes all of those tests, then it's ready to commercialize. Otherwise, we go back halfway to the drawing board. So that's what a flowchart might look like for a large project. Okay, so what does a specimen allocation tree diagram look like? At the top, it should tell how many total specimens you expect to make for the project or for a certain study or part of a project. Maybe some information about the shape or the size of these particular specimens. And then those 180 specimens in this case will be divided into 2 groups. 150 of them will come over here and be polished, and 30 of them will come over here and not be polished, but maintain a clinical surface finish on them. These 30 specimens with a clinically relevant surface finish are going to be subjected to rapid fracture testing. And this final box tells us what type of response variable or data or statistics we're going to receive from that group. So we're going to estimate Weibull parameters from those specimens. Out of these 150 specimens, they'll be further divided into a group of 120, which will be loaded and unloaded under very light mechanical loading in a cyclic fatigue or a chewing type fashion. And then 30 of the 150 specimens will come over here for rapid fracture testing And those can be compared to the data that we get from these 30 specimens in rapid fracture testing. They can also yield subcritical crack growth parameters for us. These 120 specimens that are going to be loaded in cyclic fatigue can be put in a statistical model we call a general log linear model to estimate the effect of the frequency of the cycling and the stress level on the lifetime of the specimens. So we use timelines to convince our readership that we're capable of conducting the proposed research by the deadline or by the anticipated end of the study. And there are two ways to do this. Sometimes, many times, I used both types of timelines I'm about to show you in the same research proposal. So one way is to have a calendar type of timeline. And to break it down, this is again, an example of a complicated project. So this project actually consists of 3 studies listed as AIM-1, AIM-2, and AIM-3. And it's for a 4-year period, split into half years. And for each AIM, we break that AIM or that study down into its individual steps. Some of them have to happen before the later steps, and some of them can happen concurrently, and we indicate that with overlapping arrows here, or arrows that don't interlap here. And then a large bold arrow to indicate the entire span of that particular study. And then we do the same thing for the other studies. The other type of timeline we can have is numerically calculating the total number of work hours or total number of days that are going to be required to make and test all of the specimens in the project. And so we can, for each type of specimen, list all the types of testing that are going to be done on that type of specimen. In this case, these are 2 different types of specimens that are going to be broken. One of them will have 3 different methods used to break it. The other will have 2 different types of prostheses that will be made and broken using the same method. We want to specify how many specimens, how many specimens we can make per day, or how many days per how many specimens are required. Sometimes we have to make specimens in batches, which is why it might be important to tell the number of days for 8 specimens instead of the number of days per 1 specimen. And then knowing the total number of each type of specimen, each type of test we're going to do, we can multiply by the days per specimen to get the total number of days and add those up to see how many days are necessary in the project. You never want your number of days in this calculation. The total number of days should never equal the allotted time, because you're going to have a lot of downtime and unexpected things happening in your study. And so your total number of days at the end needs to be much less than the number of days you have on the calendar before which you've promised the study is going to be finished. Then we have the section where we describe the qualifications of our team and our institute to conduct the research study. So you can list the facilities. This is about the location. And the facilities typically includes a list of all the equipment that you're sure you're going to use or very likely to use in the study. And this should be a short list. Readers don't want to get bogged down in a long list of all the equipment that you have. If you're worried that that the reader will think that your laboratory or your school doesn't have any more research equipment than what you've listed, you can also include a link to a list of all the equipment. But try to keep your list of pertinent equipment short and limited only to the equipment directly pertinent to this study. And then it may be useful to list the total amount of floor space or break that floor space down into different types of specialty laboratories or facilities. Tell how large your clinics, how many chairs, how many different type of specialty clinics, what type of laboratories you have, if you have a electron microscopy core or a mechanical testing core or whatnot. And here you can list any support staff that are not listed in your budget section later. So these would not be the support staff I'm talking about here are not the technical staff that are going to be doing hands-on work on the project every day. Here we're talking about administrative and clerical staff who are going to help to file paperwork and do correspondence with the sponsor of the study. And then in the section where you list your personnel and their individual qualifications, if you haven't talked about it in your budget section, then you'll need to mention here the individual duties that each person has on the project, and the annual effort, percent of annual effort, or number of person months or hours per year that each person is dedicating to the project. And then very important is to include the biossketch. And the biossketch is a resume or like an abbreviated curriculum vitae that describes a investigator's history of education and employment and publications and awards and honors that they've received. And very importantly, should also list the other research projects that they currently have going on or have had going on in the past few years. The last section that we mentioned is the budget. And the budgeting is a very complicated process, and I don't want to go into a topic like that in depth in this lesson. So we'll consider that beyond the scope of this series. And if you would like to know about budgeting, there are resources available at most universities. At my school, there's a graduate course, BMS 730, Grant Writing and Management, that involves 16 hours of seminars and walks the students through not only budgeting for a project, but writing a large research proposal.